Hello, my name is Walter, and I am going to be talking about the RC4 encryption. RC4 was designed by Ron Rivest in 1987, and it was a trade secret, but in September of 1994, one of the descriptions was leaked to the web, and it was kind of popularized and used by a lot of people since then. RC4 generates a key string of bits with a string cipher. This encryption is by combining with a plain text using bitwise exclusive. And it generates the key stream, the cipher makes use of the secret, and so forth. So let's talk about a little bit of the code that I have here for you. So pretty much I create this unsigned integers to use it. And the encryption text and the encryption. This takes the J and then plus the password and then mod the password length, then mod to 256 and then swap it by the S, which is right here. So like the S is just initialized and then you would just count all the way to 256 and the SJ. And then I have this other function here to swap most of the letters that is going to be in the plain text by using its size and adding the K++ right there. And then once the encryption is done, we would just push back the S, the new S, which is going to be the new characters. And then after that, it's going to go. We're going to do another pushback to it reaches the plain text. So it does all the letters and it makes all the plain text encrypted. And after that, we return the ciphertext, which is the encryption, the encrypted text. To unencrypt, it's very simple. We just run the plain text and then run the encrypt, which is this function here again, with the encrypted text and the password, and that will unencrypt the whole plain text. And then you return the plain text. Now, it looks pretty simple and pretty straightforward, but it has a bunch of flaws, and Microsoft even blocked from being used in the Edge or anything Windows 7 and above. So you can't actually use them anymore for Windows because there are many flaws that Microsoft and other people has actually found. But it does actually a good job at encrypting. Now this is what happens when we run the code. So we're going to go to option 5. You can put any text here. This is a test. You can put any character on it, and we can put any number as well. Password. And this is what we have. We have the plain text here. And this is the cipher code. And this is the plain text again when it's decrypted. Thank you very much. Bye.
Hello, my name is Nathan Spotton. I know you've got a ton of these to get through, so I'll do mine really quick. There it is working. I was the columnar transposition cipher. Those two are padding characters intentionally put there. As part of the cipher, I will do one more, the one from the instructions in the book, and there is the text, and here is the password. again, it's working perfectly, goes like that, and then goes right back. So yeah, I'll let you do the code at your own time. Thank you so much for being my professor this semester and for putting up with everything for me. Have a great day.
Hi, my name is Iberton Alves, and I created a reference cipher. Let's see one example of how the cipher works. We are going to encrypting a plain text called rocks with a key size of 3. As you can see, there is one table where the word rocks is going downwards, then upwards. To encrypt the real-fence cipher, we take the first row of the table, then the second one, then the third one, import the information in order. They don't consider these minus signs, they are just for show. And the answer for the encryption will be this one. As you can see, since the name of the plain text, since the plain text is very small, it's kind of easy to know what the previous text was. Here we have one other example of one text that was already encrypted using this cipher. As you can see now, it's a little bit more difficult to know for sure what's reading about. The way to decrypt the cipher text is simple. First, we create one empty table. We go reading the cipher text and putting it in the table as shown. First, we try to put all the letters from the first row. We go counting the cipher text and putting it dashes in the places that we don't know what should be there. After we finish putting just the first row, we then start putting the second row, and after the third and the fourth. If we didn't know that the cipher is of the key size of 4, it would be a little bit more harder to be able to decrypt this message. And since already know that when we encrypt it using the real fence cipher, we write it diagonally, so we can read the message. They are attacking from the north. To make code to create this cipher, since in C++, I'm taking the plain text and the password from a user prompt. Since the password for this code has to be one string, I created one function that would interpret the string as the integer. My idea for this function called create row size is taking the size of the password and the size of the plain text. I'm checking if the size of the password is larger than the plain text size, a third of the plain text size, then we are dividing the size of the password by 2. And we are going to do this until the size of the password give us a good encryption key. To avoid using new ifs in the loops, I decided that the size should be at least 3, since the key of 2 is also very easy to break. After taking the row size, I created one empty vector that it takes string values and call it tables. And for this vector, I put the number of row size as its value. Then I made one while loop that will be working until the number I is larger than or equal to the plain text length. Then I create two for loops. The first one that you can see, it's a for loop that will count forward. It will start from 0 and will count upwards until it's equals to or larger than the row size. Sometimes the for loop will loop even passing the plain text length, and that would give us some errors. To avoid that, I create this if statement that checks if the I is larger than or equals to the plain text, and if that happens, it has to break the loop. And as I said, after that loop, we have the backwards loop, where the first integer backwards number, I'm taking the row size and subtracting 2 from their size. Why 2? Because we are going diagonally, and since we can't put a number inside the last row 2 times at a row, then I subtract 2 to go back to the other row before the last one. And it will loop through until the backwards is equals to or larger than the number 1. Why 1? Because the forward loop already takes the number 0. Instead of doing a new if statement, it's better to just remove the number 0 from the backwards loop, and when it comes back to the start, when it goes back for 1 before the value 0, we call the upward loop if the text is not completed yet. And this way, after it, we loop through the table and put the text information, the string information, to the ciphertext, going from the first line of the table, then the second one, until the last one. The decryption was a little bit tricky, but not so much. I decided to create one vector table, but instead of putting strings inside the vector table, I put one list of chars, because for decrypting by hand, you have to loop through the text more than one time and taking out the first letter that we put in the text of the row until the end. So that's why I use the list. Since list, we can take the information from the front of the list and pop out that information. So we could avoid repeat the same letter more than one time because of some bug in the code.
Hi, my name is Philip Buller, and I'm doing my cipher lab on the Vigenair cipher. The Vigenair cipher was developed by Blas de Vigenair in the 1500s. It was based on the Caesar shift cipher. However, its security was boosted by the use of a password or key to determine the shift instead of a static number. This cipher was considered very secure for centuries and even unbreakable for a while, until it was found very vulnerable if the key length could be guessed. Currently, with modern computers, its security is very weak. However, it is used in more modern ciphers, such as the AES. The cipher uses the formula CI equals PI plus KI modulus M, where C is the cipher text character, P is the plain text character, K is the key phrase character, and M is the length of the alphabet. Like the Caesar shift, the cipher shifts the plain text a certain amount to decrypt the text. However, the Vigenair changes that shift value by looping through the key, thus making it much more secure. My encryption function loops through the plain text, and while looping through the plain text, it loops through the password or key. First, it gets the integer value of the current password character minus 31 because the first 31 ASCII letters are not used. Then it gets the integer value of the current plain text character. Then it adds the two to gain the new value. If this new value is larger than the alphabet, it is looped back to the start plus the difference. This value is then used to get the character value by adding 31 to it. And this character is then added to the cipher text. The decryption function works much like the encryption function, except it subtracts the offset from the cipher text, and it makes sure that the new value is not less than 1. If it is, it adds this number to the total size of the alphabet, thus looping back around the alphabet. Here we will give a demonstration of the program working. First, we will select my function. Then we will add the plain text. Then we will add the password. And there we have the program functioning. It takes the plain text, love everyone, treat them kindly. 2, it decodes it or encodes it, and then it decodes it. And here are my citations and my pseudocode. Thank you very much for watching my video.
Hi, I'm Mark Wright. I have completed the auto key cipher. I will demonstrate it now. The tilde did not come through. on the decipher text. And that's the only problem that I see. Thank you.